morning everyone and welcome to the NPTEL course Advanced Distribution System Analysis and Operation. Today we will start our module 7, which is Artificial Intelligence Enabled Control in Distribution Network. So till now what we have seen, that is mostly of traditional classical control mechanism or optimization mechanism. In this module we will explore that how AI or ML techniques you can use for managing the distribution network resources. So, we will see first what is AI, a little bit of background and its scope in the application of distribution network. We will see how AI enabled management you can do for distributed energy resources. We will see how you can do different distribution network management techniques like power flow, like fault clearing things that we can do with the AI, and also we will see how AI can be used for the smart consumers level. That means how you can use AI not only for the network, you can use it for the generation, you can use it for the customers as well. So, it has a very vast application in the distribution network. So, first we will see what is AI and how you can use it for the distribution network. So, what is AI? Artificial intelligence refers to the simulation of human intelligence in machines that are capable of thinking, learning and making decisions. That means we are just imitating ourselves with the help of machines. How we think by looking at certain situations or certain data or certain behavior of few persons, by looking at the different situations, how we react, that we normally mimic in the machines with the help of AI. So, the core idea of the system is to analyze data, recognize the data pattern, then learn the system by mimicking the cognitive function like problem solving and reasoning. That means the AI will look into data, it will see that whether there is a correlation between data or not, then from that correlation it will learn that how to react against that data, and that learning continues till it is getting more and more new data, and whenever the learning is finished you can test it on any situation relevant to it. Why it is needed? First thing is the classical analysis are not scalable. As we have seen, let us say we have solved OPF problem, we have seen for 123 bus system, if we go for COPF it is taking almost 8-10 minutes. Now, you think if we go for an 8500 bus network, it will take infinite number of time, it will take infinite time to give you a solution. So, that you cannot afford. So, this AI technique, they will learn beforehand and they will react instantly. So, these are more scalable, and but it needs a huge data acquiring and data storing facility, because it will learn only when you have diverse amount of data, not restricted to a single situation, but from diverse situation you have collected so many data and fed to the AI module to train itself. Then only you will get a good solution. So, the solution guarantees only get or only you can get when you have a good amount of data, and that for collecting that data you have to have a good data acquiring facility and as well as storing facility. So, what are the key features of the artificial intelligence? First thing is that learn from huge data set and adapt to new situations instantly. Reasoning, draw inference from correlated events and make logical deduction based on available information. It can do problem solving, identify and solve the problem using data analysis. Then it can take decision on learned parameter and the data analysis. That means after analyzing the data, whatever decisions it already took at the time of learning, it will act very instantly if it gets the same situation again. So, the decision making is very fast. Then perception, process and interpret sensory information such as visual and auditory data. You can give it visual data also. Then natural language processing, understand, interpret and generate human language. That means if a power operator is there, power system operator, and if he says something to the AI tool, that also can be recognized. If you have that speech recognizing capability you have given to the AI system. Then it can translate the words into text and vice versa. That means whenever we are sending, let's say one power system operator is sending data to its neighbor power system operator, it will just say in the microphone and that will be displayed to the neighbor in the text message. So, that is also possible with the AI. And also the computer vision analyze and interpret images and the videos. That means by looking at the system image, or let us say the signal image, you can interpret whether what is running in the system or what is happening in the system. So, this is the overall AI universe. Normally, we use AI and ML as interchangeably, that we say that those are synonyms, but that is not. ML is actually a subset of your artificial intelligence set. AI is the big set, it is a big umbrella. Under that, machine learning comes. So, machine learning learns the pattern from the data to make predictions or decisions through experience and data. Okay. Again, under machine learning, there is a subset which is called neural network. A system of interconnected nodes, or our human brain kind of a neurons, that process data through layers to identify the complex patterns, that will use its neural network or neurons that will learn the data and then adapt that data to take the decision. Then in the neural network there is a subset or very specific learning algorithm which is very efficient, that is called deep learning. It able to learn vast and unstructured data through many layers. In neural network you have few number of layers, but for deep learning you need a very deep network when your data are not structured properly. So, you have to extract more and more features for multiple data, and then your neural network will become smart enough to take a good decision. But when it is trained properly, at that time you can see that it can take decisions very faster compared to a conventional neural network. Then you have generative AI, what we are doing using now as a ChatGPT or Gemini AI. What you are doing? You just give him a text or you asked him that I want this answer, and it will generate the answer whatever learning or whatever data set it has already in his library. So, this is the generating AI. So, creates its own content by learning from existing data and generating realistic output. So, this is the overall AI universe. So, how the AI learning algorithm works? AI learning algorithm works in the method that allows machine to learn from data and enhance their performance over time. That means now you give a certain amount of data, training data to the AI model and you trained it, but it is not there, you are stagnant. Periodically you have to update your training data and accordingly you have to train your AI module, otherwise your AI module cannot adapt the newly variant situation. So, by adjusting the internal parameters based on the input data, the system becomes better at making accurate predictions or decisions. Okay. So, what we do? We give an labeled or unlabeled input data to the learning AI module. What it does? It's learn the parameters and adjust the internal parameter based on the data and the objective. Then that will be given as an output as a prediction or the estimation that will predict the future events, classify the data or take action against new inputs. This means your response to the certain event. If that estimation or the prediction is not true, that means let us say you expected 1, but you got 0.5 as an output. That means that is not a true output. So, you have an error of 0.5. That error you have to feed back to the learning parameter adjustment process again. That will say, okay, my error is not 0. When the error is 0, that means your learning is completed. At this time, my error is not 0. So, if it is not 0, that means you have to again learn, you have to adjust your parameters again, that the error will now reduce and it will move towards the 0 value. Okay. So, with this, if we see the AI learning algorithms, that if you give a data set of particular input and the output, that means if you have to give the input feature, you have to give the corresponding output feature as well. Then only it will learn, it has to know where to go first. with the training data, that if this situation arises, how to respond to that situation. Then it will develop the model with the learning parameters, that which parameters it has to learn with the function f, with the input data and also the learning. Then it will derive a loss function. That loss function will guide him towards the proper training. That means if the loss function is 0, and that is mostly defined with the mean squared error or mean absolute error or cross entropy, that means everything is error. So, if that loss function is close to the 0, that means your error is close to the 0. If your error is close to the 0, means your training is perfect, and your whatever parameters you have set at the time of training, those are perfect for your situation or according to your data you have fed. So, if that is the case, then your training is complete. So, if you see the parameter update, update the learning parameters using gradient descent method by minimizing the total loss because of all data points. So, minimize the total loss, that is your objective function, and you use the gradient descent algorithm to update your del theta, and then you reduce your or increase or update your parameter value theta depending upon whatever perturbation you are getting after minimizing the loss function. Okay. So, iteration repeat the process with theta equals to theta nu, then that means with this theta nu again you will solve your loss function and you will get how much loss you are getting. So, if you are getting that and if the loss value is lesser than the tolerance value, then you have got the output or you have trained your model properly. If it is not, then again do the iteration. Okay. So, there are mainly 5 different learning algorithms in the AI. First one is a rule based, second is supervised, third is unsupervised, fourth is reinforcement, and last is evolutionary or nature inspired algorithm. What is rule based AI algorithm? Rule based AI algorithm says that for a machine learning approach where the system learns or applies a set of if then rules. That means if something happens, if x happens, then y is there. If this kind of rule we set for a certain learning, then to make the decision and the prediction, that is called a rule based learning, and those rules are fitted in the module. Then you need not to have a huge data set, you will just fit the data for the rule based system. That means, let us say we say if the load is greater than let us say 10 megawatt, then your battery will discharge let us say 1 megawatt. If again this is if, then this is then, and here you will also have an if rule that your SOC level is greater than let us say 0.6 per unit. So, we set 2 if rules and then a then or a decision rule. Okay. So, if this kind of a set of rules, for that you need not to have whatever the load you like previous load historical data. It will just at the real time it will take the value, it will sense the load data, it will sense the SOC data, and you will see whether this falls under the rule or not. If it falls, then it will act accordingly. If it does not fall under the rule, then it will just eliminate that and it will search for the next rule. So, this rules are either manually defined by experts or automatically extracted from the data during training. So, either you can manually set it, or if you want to make it automated, then you can feed certain amount of data, and by looking at the data, let the system decide what is the if then rule. That means, how you already behaved at your past time when the transmission or the network operator has done that manually. So, that data record is there, you fit that data record to the AI module, and then it will derive its own if then rule. So, the fuzzy logic is the best example of this if then rule, where we use the Mamdani function or membership function to define the if then rule, and those are overlapping with each other. So, and also when combined with the neural networks This ANFIS, that means Adaptive Neuropathy Interference System, is also now coming as a rule based network. Then the next is the supervised learning. What we do in the supervised learning? In the supervised learning algorithms, we use level data. That means if X is the input data, then Y is the output. For each and every input, we have a targeted output. So, where each input is paired with a known output, allowing the model to learn mapping between them. That means when it is training with the X and it is not getting Y, or let us say it is getting Y1. So, this Y minus Y1 it will calculate, and that is the loss function for it or error for it. Then that error will be fed back to the module to learn or to train it properly. So, the model generalizes from the training data to make accurate prediction on unseen input by understanding the relationship between the input feature and the targeted output. Okay. Few examples are your linear regression used for predict continuous values, you have logistic regression, binary classification, you have decision trees for classification process, you have random forest, you have support vector machine, k nearest neighbor, naive Bayes and other methods as well, and all the neural networks like your artificial neural network, your convolutional neural network, and also your recurrent neural network. So, all the neural network comes under supervised learning, where you give an input data and also give the output for it for the training purpose. And when it is trained, now you give the testing data, where you do not give the output, only the input, and see the accuracy. Now, what is unsupervised learning? For unsupervised learning, there you have only X, not Y. That means you have only the input data, but you do not have the output data. Those are not unlabeled data. You just gave a cluster of data to the learning module and let them decide the pattern and the structure without explicit guidance. So, that is why it is called unsupervised. There is no output to supervise the training process of that AI algorithm. So, this is useful for tasks like clustering. That means just see the features of the data which are in proximity with each other, then cluster them together. Okay. You cannot say that those are perfectly this situation, but at least you can say this all this data are from closely same situation. So, cluster them. Dimensional, you can do dimensionality reduction or you can do anomaly detection. That means you can say whether your system is running in healthy or running in anomaly. You cannot say which anomaly. For saying which anomaly, you have to give the supervised learning. That means whether it is a fault or it is a power swing or it is a stability concern, what anomaly, for defining that you need supervised learning. The data you will give, and according to the data you will say that okay, if this amount of current is there, then it is a load enhancement. If it is this much of current is there, then it is a line to ground fault. Then if this much is there, then line to line fault. For saying that, you have to have the supervised learning or level data. But with the unsupervised learning, at least you can recognize that this much of operation has the same nearly same values. So, they are healthy only or they are anomaly only. They are not working under healthy condition. So, this binary classification between this healthy and the anomaly operation of the power network is possible with the unsupervised learning. So, that is same as like a clustering thing. You cluster all the healthy things together, you cluster all the anomaly things together. So, for that we normally use k-means algorithm, hierarchical clustering algorithm, density based spatial clustering algorithm, principal component analysis for reduction of the data, that will say that okay, if you have multiple data, huge amount of data, we cannot deal with that. So, reduce the size of the data. For reducing the size of the data, what we do? We take which data are close to each other, cluster them together. So, that is done by principal component analysis or compressed sensing. Then you can use autoencoders for feature learning and anomaly detection. Then reinforcement learning. What is reinforcement learning? Reinforcement learning happens by interacting with the neighboring environment. That means you do not have labeled something, also it is not unlabeled. So, what it does? It takes an action, the AI module will take an action and it will see whether that action is giving you benefit or not. If that action is giving you benefit, then it will give you a reward. That means you have done a good job. So, you are capable or you are able to get a reward. But if your move is worsen the situation, that means let us say your battery system is SOC is already at let us say 0.3 per unit, and your AI algorithm says take discharge out of it. So, what will happen? It will reduce to 0.2 per unit. That means you are stressing your battery. If that is the condition, that means you are worsening the situation. If that is happening, then you deserve a penalty. So, it will give you a penalty term. So, after doing few trial and error process with the learning algorithm, it will see which move will give you reward and which move will give you penalty. So, the optimal behavior will be derived by maximizing the number of reward. That means, you take an decision and let us say it will give you a reward. For next decision, you have let us say two possible ways of going. One is giving you reward, one is giving you penalty. Again, from there you have two process or three process, let us say. One is giving you higher reward, one is giving you lower reward, and one is giving you penalty. So, it will try to track the path which will give you the maximum reward, and that will be the process of the learning for the reinforcement process. So, it is a trial and error reward and penalty process. There is nothing supervised, there is nothing unsupervised, and the reinforcement learning is the most promising learning techniques to control the operation of distribution network resources. So, we use Q learning, we use state action reward state action learning, this is SARSA with the help of Markov decision process, and we use deep Q network which combines the Q learning with the neural network. The evolutionary algorithms which generates the huge number of population from the data set, and by doing some mathematical operation or updating the solution points or the population by mimicking the natural phenomena like biological evolution, swarm behavior or natural selection, the solutions has been updated or the solution has been derived. So, generally we use genetic algorithm, that is a very good method. Differential evolution, particle swarm optimization, ant colony, artificial bee, firefly, and henceforth. There are so many evolutionary algorithms were there, and still the researchers are developing to get faster convergence. The only problem with this kind of an evolutionary algorithm is that they are slower convergence rate, and second thing is that the learning process may not be always efficient and you may stuck to the local solution, and it highly depends upon what is the size of your population you took at the initial stage. So, if you derive it like this, if your size and everything is fine, and if your system is very complex, that means if you cannot model your system properly, so at that time generally we go for heuristic optimization, that you will give a population, you get the response out of it and see whether this response is feasible or not, or feed so many solutions, probable solutions, those are your population values, and get the response from all of them and decide which is giving you the best, and then this is your learning process. So, what are the AI learning parameters? Your learning parameters, these are the parameters which are learned or tuned during the learning process. That means, actually those are your decision variables at the time of training that you are actually tuning. So, decision variables in the learning process, weights and bias for the ANN, that means if you have this kind of an architecture for ANN, and we know that every time we have an weight plus bias, that means output of each node is actually some weight multiplied with the input plus some bias value. So, it will learn this W and this B value, And if your W and this B values are learned properly, and then your training is good, and then you can use that same W and B value for an test data, and you will get a good result. Okay. So, weights for ANN and SVM, filter weights for CNN, because we use normally filters for doing the convolution operation with the input feature map. So, those filters are the parameters, learning parameters for your CNN. Forget gate weights and biases for your LSTM, centroids for your k-means, and eigenvectors for your PCA algorithm. What are the hyperparameters for your learning algorithm? These are your input parameters, these are not decision variables. These are pre-specified, which are required to control the learning process. These are like the, in our optimization algorithm also we have seen that you need some input data to guide the solution process. These hyperparameters are also like this, they will guide the learning or the training process of the AI. So, the few hyperparameters are learning rate, which controls how much the model updates in response to errors. Then you have batch size, number of samples processed before updating the model. You have number of epochs, how many times the algorithm sees the entire data set. Number of hidden layers in the neurons, in neural network this affect the model capacity. This means how many hidden layers you will give for the neural network, and also how many neurons you will keep in each and every neural network. That is your hyperparameters. Then you have regulation terms to prevent the overfitting. So, what we use AI in traditional power grid? It is not like that we are in the using AI in the power grid. It is using from almost 1 decade back. But how you are using? First, we can use this for the load forecasting. Generally, obviously, if you are doing the scheduling today or you are clearing your day ahead market for tomorrow, so you have to first predict your load consideration. So, that is the load forecasting generally we do. Then hydropower plant operation, because that depends upon the logic that how your thermal power generation and the loads are present, and thermal power generations are generating. Depending upon that, you will set the fuzzy logic Mamdani function or the membership functions to get the hydropower operation. Then economic load dispatch of the thermal power plants, we can solve unit commitment, we can solve generation expansion planning, and also the demand management process. But the new age distribution network also need AI enabled support system for smooth operation. Previously, generally all these operations are done for transmission network, because in the transmission network only you have responsive generators and responsive loads. But now in distribution network also we are getting DERs and customers involving in the demand response program or demand side management. So, we need AI tools or smart decision tools in the distribution network as well. So, why AI in distribution network? It handles complexity and nonlinearity. AI can model complex nonlinear systems more effectively than classical mathematical models, enables real-time decision making, it learns and adapts automatically, as we have already discussed. It is scalable and efficient, improved prediction accuracy, tolerant to noise and uncertainty. That means, if you give diverse amount of data of diverse situations, it can learn from that, and if you little bit of deviate from your trained data, still it can accommodate the deviation and give you a good result. It can recognize the pattern and it will give whether your system is running in a healthy condition or in an anomaly condition. So, these are the typical application area in AI. In distributed generation area, you can do for generation forecasting, smart inverter control, or storage and EV management. For network purposes, you can solve the power flow problem, you can solve the fault detection algorithm, OPF problem, demand forecasting, network topology estimation, and also you can ensure the cyber security through the AI tools. The smart prosumers at the consumer level, you can do the appliance management, energy management, demand and price forecasting, renewable generation forecasting, and the power quality assessment with the help of AI tools. With this, I will end today's lecture and will continue with the application of AI in the DER's field in the next lecture. Thank you.